Right, the first part which we are supposed to look at, we are looking at numbers. We are looking at numbers. On this part, we are looking at the idea of terms. That is the first part. I'm being given a situation where I'm writing something like 2x, I'll say to the power of 2. I will say this one as it is being referred to as a term. It is a term as it is. Meaning to say, what are we having now? We are saying it is a term. We are saying the 2 here is now being referred to as the coefficient of an x. Then here is my x. I will say my x is referred to as the unknown. Right, then the 2 here which I have, it is now being referred to as the power index. Right, what do I have now? I have 3 items. I have the coefficient, which is of an x, and I have an x, which I'm going to say today, it is my unknown. Then this one, the power 2 is the power index. We are saying it is the power index. Some refer it to as an exponent. Then we are saying now, taking in mind now on the idea which we say an x here. An x is an unknown, and it can be a y, it can be m, it might be z, or any other letter of the alphabet. It might be any letter of the alphabet. Meaning to say now, we are supposed to know this is a term, and this term is referred to as being positive. What do we mean when we say positive? We are saying the sign in front of a 2 is now being referred to as a positive. It might be positive, it might be negative. Also, the exponent which I'm having here, it might be a positive or it might be negative. That is the introduction of a term. That is what we refer today as a term. Right. What do we have now? We are now saying, how do we come up with these numbers? How do we work with these numbers? Let us see how to work up with these numbers. How these numbers came into play. What we have? We are having a situation whereby I come up with a line. I will say this one is I refer it to as a number line. It is my number line. This one is my number line. Right, what do I have on my number line? I'm saying, from this part, this one is a 0, then I say 1, I say a 2, I say a 3, I say a 4, I say a 5, I say a 6. Right. Now, on the other hand, coming to my left, I will say -1, -2, -3, -4, -5, -6. Just going like this, I will be having negatives. Meaning to say from 0 until to your left, to your far left, the numbers, they are negative. Meaning to say I'm going to put a negative here, then on the other side, I'm going to put a positive. Meaning to say now, it gives us the notion that from 0, my numbers tend to increase. They increase in value. The value of the numbers tends to increase from 0 going to your right. Then on the other hand, from 0 to your left, the numbers tend to decrease. What do we have now? If I start from -6 here, going this other side, I will say my numbers are increasing in value. They are increasing in value from this part until to this part. Meaning to say, from left to right, the value of my numbers is increasing. Meaning to say, at the same time also, my numbers tend to decrease from this point until this other point. Meaning to say now, we are supposed now to use this number line in order to solve what? Our direct numbers. We are supposed to be able to solve our direct numbers. Meaning to say now, I'm going to say a 1, I will say a 1 is greater than a 0. Why? Because a 0 is before the 1. Meaning to say, I will say a 3 is also greater than a 2. Or it might be greater than a 0. Alright. Coming on my other side, on my left hand side now, what do I have now? I have said the numbers, they are decreasing. Meaning to say minus 1 is also greater than minus 10. If I go to this direction, I will find a minus 10. A minus 1 is greater than a minus 10. Right, what do we have now? We want now to complete an idea of taking those values which we tend now to say, how do we use the number line? How are we going to use the number line? Let's say I'm being given an example to say you are supposed to come up with the answer, you are supposed to solve it. Let's say I'm just being given these direct numbers. Direct numbers are simple numbers. They are simple numbers, meaning to say from 0 until going to your positive side, we have said that they are positive integers. Then these ones, they are negative integers. Negative integers, an integer is just a number. Right. What do we have now? We are saying these are also referred to from 1 to this direction. We are also saying they are being referred to as a counting number. Because if we count, we never started counting, saying, if we are being asked how many people are attending the class, you can't start by saying 0. There is nothing which is called a 0, meaning to say we start from 1 until a 6, meaning to say those are counting numbers. Proceed now. We tend to say 0 doesn't have a charge. 0 doesn't have a charge. We are saying it is neither positive nor negative, meaning to say it doesn't have a charge. Right, coming to these direct numbers, how do we solve them? I'm being given there are numbers which, if you look at the kids, they are bored. In order they are bored to solve these direct numbers. Let's say I'm given minus 3, minus 4. Minus 3, minus 4. The first one, I go to my number line on my minus 3. Yes, my minus 3. Right, which direction should I go? I am looking at the sign which follows. The sign which follows is a minus. I go this other side. But if here it was a positive, I was going to go this other side so that I can find a positive. But because I don't want to find any positive, I continue going to my left. Then they are saying minus 4, meaning to say I'm supposed to count from this part, I'm supposed to count 4 steps. 1, 2, 3, 4. Meaning to say your minus 7. Your minus 7 will give you the answer. The answer will be a minus a 7. This is my minus a 7. Meaning to say if that is my minus 7, if I'm being given another expression again, they say minus 2 plus a 6. What do I get? Let's say plus a 4. Plus a 4. Now, here I go to minus 2. I encircle my minus 2. Then the sign which follows is a plus. Meaning to say I'm supposed to go to my positive. I'm supposed to go to my positive. How do I go to my positive? I'm supposed to count 4 steps going to the positive. Let us see. 1, 2, 3, 4. Meaning to say I count the number which I get there when I'm done with the positive. Meaning to say my answer is a positive 2. It will give me a positive 2. That is the way which we apply direct numbers. Right, then there is a situation. I'm being given now a situation that says minus 3 minus minus 2. This is an expression which I'm going to say minus 3 minus minus 2. You are supposed to be able to solve it using the idea of the number line. How do we do that? If you are being given 2 negatives following each other, automatically they change to be a plus. Meaning to say my answer now becomes minus 3 plus a 2. Meaning to say I go to my minus 3, this one is my minus 3, then the sign which follows now is a plus 2. Meaning to say I'm supposed to go to the right, then count how many steps? 1, then I say 2. Meaning to say my answer now becomes a minus a 1. Meaning to say that is the idea which we're going to use to solve direct numbers. Right, now let's say now we are having minus 1 minus 3. I will say minus 1 plus 3. Minus 1 plus 3. What do I have now? I'm going to say, if this is the situation, I say minus 1 plus the 3. We are saying it is being simplified to be minus 1 minus 3. Why are we saying so? We are saying whenever there is negative and positive, negative has got more power than the positive. And also, we are now being left with what? With a negative. With a negative. Then we use the same criteria again. We go to our minus 1. Minus 1, counting this other side, we are saying minus 1 minus 3. Minus 3, we are not going to this other side because if we go to this other side, we're going to meet a positive, meaning to say we are supposed to go the other side. The other side, which is a what? A minus. Then we say minus 1, here's our minus 1. 1, step number 1, then step number 2, step number 3. Meaning to say my answer here will be at negative 4. Meaning to say my answer now is a negative 4. That is the answer at the end of the day. Meaning to say now, people, they are now having a confusion. We are now having a confusion. Meaning to say, if I'm being given expressions, those expressions, what makes the expressions difficult? Now we go to our term, which is 2x. The thing what people now say it is difficult, it is because we have included an idea which we refer to as an x. Meaning to say, an x, just take it as any number. Just consider it as any number. Why I will say it is any number? We are now saying, okay, in mathematics, in algebra, we are saying this idea is being used in algebra. How is it being used in algebra? We are saying it is being used, it is the use of letters in order to represent quantities. It is the use of letters to represent quantities. That is algebra. Meaning to say, if we say 2x, it is 2 times an x. 2x is 2 times an x. 2 multiplied by an x. Meaning to say, let us see to it now. If I say, let's say, one loaf of bread is 10 rands. Right. One loaf. If we are saying 2 loaves, what we get now, we are saying, we just say 2 times a 10, which is 20 rands. That is the price of 2 loaves. If we are saying 4 loaves, if we are saying what about 4 loaves, I will say 2 times 10, meaning to say it is 4 times the 10, which is 40 rands. Meaning to say now, what if I say x loaves? X loaves, what will be the price of x loaves? Just follow the wave, follow the direction. Here we said 4 because there were 4 loaves. Now here we said 2 because there were 2 loaves. Now we are saying x, they are the number. So we are just taking that letter to represent the quantity. Then I say times the 10, which is, meaning to say the price will be 10x rands. Meaning to say it will be 10x rands. I'm just using number letters to represent quantities. If I am asking now, why loaves? If the question says why loaves, what do I get now? Y loaves. I will say it is a y multiplied by a 10. Then I will say it is 10y, that is 10y rands. Meaning to say, we are not supposed to be shocked by including what? An x to be including letters in our day-to-day calculations of mathematics. Why are we saying so? We are saying they are just numbers. We are using numbers in order to what? In order to come up with what? With our numerical value of quantities. Meaning to say, that is the idea of algebra. Meaning to say now, we are supposed now to have a situation whereby we are in a position to add and subtract direct numbers. We are supposed to be able to add and to subtract direct numbers. And that idea of adding and subtracting direct numbers using the number line, it will be the lesson which is going to form. Thank you.